Jai Hind viewers, my name is Pankaj Singh, Faculty of IT Department. Today I am delivering my first video lecture on a topic of kernel. It is a topic of operating system. So in this we will discuss what is kernel and its type in detail. So let's start. These are the outlines of my video lectures: Introduction to OS, relation between OS and kernel, what is kernel, role of kernel in operating system, and in last, type of kernels with their differences. So first we go to the definition of OS. As we all know, what is OS? Operating system is a software. So first we know which type of software is a operating system. As we all know that software is generally divided into two categories. One is application software and second one is system software. We know many application softwares as we use in our system or in mobile phones. Just like in simple term, if I say in mobile we use apps, and in computer system we use different just like Microsoft Office. These are the application software in which we will do different type of tasks related to our office work. So now come to the type of software. Which type is software? It is a type of system software. So system software further classified into two categories. First one is utility software and second one is operating system. Our concern is here is regarding operating system. So operating system consists two parts, or we can say two interface to interact. One is used to interact with the user and second one is used to interact with the hardware of a devices. So operating system generally consists two interface, first shell and second one is kernel. And our topic is today's kernel, but before going to the kernel we must know what is the role of shell and where it is lie within a operating system architecture. In general, if we consider it is a operating system, right? We have a hardware. After that, hardware is operated by or controlled or interact by the help of kernel. After that, we have shell, and with the shell, user interact. And to the hardware, interaction is possible only by the help of kernel. And this interaction is done by the technical term we use here, system call. What is system call? System call is used to operate or give the instruction to the hardware by the help of kernel. So all the functions of a hardware is operated by the help of system call, that is go through by using medium of kernel. So hopefully it is clear for the brief introduction about what is operating system and where it is lie. So today our concern is about kernel. What is kernel? Type of kernel? What is the basic difference between different type of kernels? So let us start. Hopefully it is clear. Now have a brief look about as I said earlier, the definition of operating system. What is operating system? Operating system is a system program, as I explained in a previous graph, and that run on a computer to provide an interface to a computer user that can easily operate on a computer. So as we see different layers or the interaction level, where operating system is lie here. Above operating system we have two layers. One is application layer and here is a user. But user cannot directly interact with the hardware. It is done by the help of operating system, and operating system consists two layers. First one is shell and second one is kernel. As we see in a given diagram, shell is responsible for the above operations and kernel is responsible for the lower end operations, that is related to the hardware, and shell is responsible for the interaction between user to the application layer, and then it will go to the hardware, and always all the operations to the hardware is operated by the help of kernel, and it is done by the system call. Now come to the, in brief, the functionality of operating system. As we know what operating system does in a machine, it manage processor, it manage memory, it manage security, it manage file, it also detect and correct the errors within a machine. These are the, just for introduction or just for brief about the functionality of the operating system. Now come to the next thing, what is the relation between OS and kernel? There might be some confusion to the students, is a kernel is a part of OS or OS is a part of kernel. So in a given block diagram, it is very clear, kernel is a sub part of a operating system, right? It is live within a operating system, and all the hardware interaction is done by the help of kernel. Now come to the technical definition of kernel. What is kernel? Kernel is a core of the operating system, as I said earlier in a previous slides. It is the first program of operating system that is loaded into the main memory to start the working of a system. So hopefully it is very clear with the definition. Without kernel, the hardware interaction or using the services of the hardware connected with the machine, either it is a memory, it is IO devices, is not possible without the effectively working of the kernel within a machine or kernel live within a OS. Secondly, till the machine is running, kernel always lie in a main memory at that time. Kernel remain in a main memory till the system is shut down. When we again restart the system, it is again loaded to the main memory and control all the operations regarding all the hardware interaction that is done by the help of system call, that is passed by the user. And it is, we can say, the nucleus of a computer system that operate all the operations related to the IO devices, memory and other connected devices. As I read forward, kernel basically translate the commands entered by the user in a way to make the computer understand that what user has request. So I said many times, it is a work just like an interface. It will take the input from the user and convert it into the machine language and pass to the hardware devices by the help of kernel. Now, how many type of kernels? Or before going to that, we must know the role of kernel in a OS. Here, kernel act as a bridge between application software and hardware of a system. As we have in a previous slide, as we see here, kernel and shell is responsible for the user interaction and kernel is responsible for the hardware interaction. The same thing is explained here, work as a bridge between application software and the hardware. How they will request a memory or how they will require the different parameters, or all these things is managed by the help of kernel, working as a bridge between application software and the hardware. Now come to the second point, kernel directly communicate with the hardware and let it know what the application software has request. The request of the application software go to the shell and shell it transfer it to the kernel, and finally the kernel communicate it into their own mode to the hardware device what exactly the user is requested by the medium of the application software. It will be implemented by the help of kernel. Third, an operating system is unable to run without the kernel as it is a important program for the working of a system. As I said in a previous slide, it is a core of the operating system. It is load as we start a system till the shutdown of the system. So, it is the important program. Without kernel, it is not possible to interact with the hardware device directly. Next point, kernel take care of what kernel does in a machine. Their task is very similar to the all the functionality related to the functionality of a operating system. Just like what operating system exactly do, it manage memory, process, task. The similar all these things in a deep down level is done by actually kernel. So, these all task is same as the functionality of OS like memory management, process management, task management, memory space management, and all these operations as we discuss in detail in functionality of OS, all the functionality is same implemented by the help of kernel in a operating system. Next point, it create and restrict memory which help in execution of the software. So, the memory space required for execution of a program or destruct means delete the memory space for execution of a software, it is done by the help of kernel. So, by the help of above this point, the importance of a kernel is easily understand within a operating system, because all the functionality what our OS does is done by the help of only by the help of kernels, and it is also act as a bridge between the application software and the hardware devices. Or in simple term, we can say that it work as a lubricant between the user applications and the hardware devices. Kernel is also a system program that control all the programs running on a computer. Kernel basically bridge between software and hardware of a system. If we talk in a broad perspective, because in a previous point we discuss in a micro level, it is a interface between a hardware devices to the system software, but in broad perspective we can say that it is an interface between hardware and software. So, one question is arise, if all these operation is done by the kernel, so we can say OS and kernel is same? No. We have a difference between kernel and OS here. The basic difference that distinguish kernel and operating system is that operating system is a package. Hopefully, you can understand here concern is package of what? Data and the software that manage the resources of the system. And what is kernel? Kernel is a program that lie within a OS software. So, operating system is a collection of data and software, and kernel is a part of software, and it is a program that operate all the hardware operations. So, it is a basic distinguish between operating system and kernel, because as I said earlier, it is very similarity between the functionality of OS and kernel is almost same. So, might be there are some confusion, the OS is same as the kernel, but no, it is the basic difference is here, it is a package of data and software, but what is kernel? Kernel is a part of a software that work as an interface between the user applications and the hardware. Hopefully, the functionality or we can say role of kernel in a OS is clear. Now, come to the type of OS. Here we have three OS over the three type of kernels over the slide. First one is monolithic kernel, second microkernel, and third one is reentrant kernel. So, what is the basic difference? What is their basic working in term of access the hardware or using their space? Let's have a definition of monolithic kernel. The monolithic kernel manage the system resources. What is system resources here? Memory, IO devices, networking, security, and so on between application hardware of a system, but unlikely as we go after that the in detail the difference between monolithic and microkernel, but unlikely the microkernel, the user service and kernel service are implemented under the same address space, but in monolithic kernel it is implemented in a different address space. What is the basic difference between using the same address space or different address space? We will go into the detail when we discuss the distinguish between these two methods. Second, this increase the size of kernel, further increase the size of operating system. So, we can say that it is a drawback of a monolithic kernel because it use the different address space for the different processes. User service and kernel services are implemented in a different address space. So, because of that the size of operating system may be or would be bulky as compared to the microkernel. As we have a architecture of a monolithic kernel, as we see in this diagram, it use different address space to implement different services, just like user interface is used in a different address space, business logic is used in a different address space, likewise data interface, and it communicate with the memory. So, because of this it required more memory as compared to the microkernel, and it make it a bulky as compared to the microkernel in term of memory size. What is microkernel? Microkernel being a kernel managed by all system resources. What system resources? I said earlier. But in a microkernel, the user services and the kernel services are implemented in a different address space. The user service are kept in a user address space and kernel address space. This reduce the size of a kernel and further reduce the size of a operating system. As we have a block diagram over there, it use a user mode or we can say user interface in which such operations or such contents will lie like file system, thread system, paging and segmentation. We will go in a last unit about that. Command line interpreter 1, command line interpreter 2, network support in a user mode, and kernel mode consists support from the primitive links like process, memory and messages, and it interact with the hardware, or we can say memory, IO or other hardware components that lie or required for a system. So, it is a basic difference between micro and monolithic kernel. Now, to understand the basic difference in a term of their functionality or technicality, as we see over a screen, these are the parameters who help to understand the basic distinguish between microkernel and monolithic kernel, right. So, first is the major point, what is that is address space. In microkernel, user and kernel space are kept in a separate address space, as we see in a previous slide, one in user mode and second one in kernel mode. But in a monolithic, all these lie with the same package. Due to that, the size of a operating system is increased, and we can say it is a bulky as compared to the microkernel. Design and implementation, but obvious, if we use a different address space for a user services and kernel services, the working is complex as compared to the monolithic. So, we can say the working of microkernel is complex because of different design parameters used in this method. If we compare these two methods in a term of design and implementation, monolithic kernel is easy. Next, size. As I said earlier in a first point, the size is smaller as compared to the monolithic kernel, because all these services will lie in a different address space. If we talk about their functionality, the functionality in microkernel is easy to add new functionality because we use different address space for user and kernels. If we want to add any kernel services, we can easily go to the address space and add that, and similarly we can easily add a user services in a user interface phase. But in a monolithic kernel, it is difficult to add any additional services. Likewise, coding. To design a microkernel, more coding is required. In a monolithic kernel, less coding is required as compared to the microkernel. So, these terms are in comparison to one another. Less coding means here we can't say that we can easily code or design a OS by using monolithic kernel, but when we compare these two things, it is a easy as compared to the microkernel. The major concern why we use microkernel at a place of monolithic kernel, that is a failure parameter. As I read here, failure of one component does not affect the working of microkernel, but in case of failure of one component in a monolithic kernel lead to a failure of the entire system. That is the main drawback why we use microkernel at a place of monolithic kernel, because in this case the whole system will crash, but in this case only the concerned address space, or we can say the concerned services will affect it, but in this case the whole services related to the OS is entirely failed, but in this method the concerned service will fail. That is the main reason why we prefer microkernel over the monolithic kernel. Processing speed. If we talk about speed, the speed of monolithic kernel is high as compared to the microkernel. Extendability means additional of services. As I said in a second point, it is very easy to add any services in a microkernel, but in monolithic kernel it is not easy, or we can say it is not desire in a monolithic kernel to add any services. Communication. To implement IPC messages, queues are used by the communication microkernels. In this method, monolithic signal and sockets are utilized to implement IPC in monolithic kernel. And last point, debugging. To find out the error. To find out the error is very simple or very easy in a microkernel, and it is difficult in a monolithic kernel. So, after going through these points, we can easily differentiate or find out the kernels according to our needs, which type of kernels we required. If our services is frequently changed, or we want to add additional services to the existing running operating system, so we will go through the microkernel. And if our services is fixed, we will prefer monolithic kernel, because in this we have one advantage, the speed and coding is fast as compared to the monolithic kernel, and coding is less required. But the major drawback was that if one service is failed, the all services will affected in a monolithic kernel, but in a microlithic kernel only the concerned services will fail, other will execute or in a running mode. After going through these parameters, we can easily differentiate or find out our OS as per our requirement. It is a third type of kernel, that is a reentrant kernel. What is reentrant kernel? A reentrant kernel enable a process to give away the CPU while in a kernel mode. Okay, one of the important point, when OS or we can say kernel interact with the hardware, no other services can access the hardware devices, but by using reentrant kernel it is possible. How it is possible? They do not hinder other process from entering into the kernel mode. This behavior allows CPU to share among multiple processes. Next, when a reentrant kernel, the scheduler will assign the CPU to the another process until an interrupt from the disk controller indicate that the data is available and our thread can be resumed. So, when there is a no interrupt to the OS, it may be hand over to the other services until read and write operation is initiated by the disk controller, or we can say data availability to our thread can be resumed. Next point, if a hardware interrupt occur, a re-entrant kernel is able to suspend the current running process even if that process is in a kernel mode. So, it is a major advantage of this mode of kernel. If a hardware interrupt occur, if any input is given by the hardware or we can say initiated by the machine, a re-entrant kernel is able to suspend any current running process even if the process entered into a kernel mode. So, what we can understand here, the priority will be assigned or we can say given to the hardware interrupt, not to the process running into a current state in a kernel mode. This capability is a very important because it improves the throughput of the device controller that issue a interrupt. So, in monolithic kernel and microlithic kernel, this facility or this availability is not possible, but in this case hardware interrupt is kept above the process running in a kernel mode. In previous two methods, if a process is running in a kernel mode, nobody will interrupt to the OS, but in this case or by using re-entrant kernel, we can easily give the priority to the hardware interrupt or we can say the component that lie within a system. It can overcome the running thread or running process that in a kernel mode. By the help of this, the throughput of a machine or in simple term we can say output of a machine or a system is increased as compared to the previous two methods. So, hopefully it is clear to all of you what is operating system, type of operating system, and after that functionality as we go through once, and after that I go to the kernel, type of kernel, in which we go three parts or we can say three types. First one is microlithic kernel, second one is monolithic kernel, micro kernel, and third one is re-entrant kernel. Thank you.